Hi guys, don't forget to subscribe my channel and like this video. Okay, enjoy!
Next, we move to the synthesis of carboxylic acid. In this syllabus, I just share 4 reactions that can synthesize or produce carboxylic acid. First reaction is the oxidation of primary alcohol. In this reaction, when the primary alcohol reacts with oxidizing agent, either chromium trioxide, potassium permanganate, or potassium dichromate, it will form the carboxylic acid. Part CH2OH will oxidize and rearrange into C double bond O OH. You can revise also this reaction in the chapter alcohol. Second reaction is the carbonation of Grignard reagent. It starts with haloalkane reacts with magnesium in the presence of ether to form Grignard reagent. Then, the Grignard reagent go through the carbonation reaction when it reacts with carbon dioxide in the acidic medium to form carboxylic acid. This reaction also you can revise in the chapter haloalkane. The third reaction is the hydrolysis of nitriles. In this reaction, nitriles will react with water in acidic medium in the presence of heat. The hydrolysis of nitriles, which are organic molecules containing a cyanyl group, leads to the carboxylic acid formation. The mechanism for these reactions involve the formation of an amide followed by the hydrolysis of the amide to the acid. Last reaction that can synthesize carboxylic acid is the oxidation of arenes. Treatment of any arenes with potassium permanganate results in oxidation to give benzoic acid. Let's look into some examples. Based on these examples, I just want to show that different reactions can synthesize the same product. In the oxidation of primary alcohol, when butanol reacts with excess chromium trioxide, it will oxidize alcohol into aldehyde. And further reaction will oxidize the aldehyde into carboxylic acid. Final product, it will form butanoic acid. In the second reaction, chlorobutane first react with magnesium in ether medium to form Grignard reagent. Then, the Grignard reagent react with carbon dioxide in acidic medium to form butanoic acid. In the next reaction, the hydrolysis of butyrolnitrile in acid medium will lead to the formation of butanamide first. Then, further hydrolysis will synthesize butanoic acid from butanamide. In the last reaction, the oxidation of toluene in potassium permanganate will synthesize benzoic acid. Let's say, if the isopropyl benzene react with potassium permanganate, it will also synthesize benzoic acid. In other words, benzoic acid is the only product whenever any alkyl benzene go through the oxidation reaction. This page will be your exercise. Take a deep breath and try to complete the reactions. Refer the previous page to answer it. You can do it. And this is the summary of the reaction that can synthesize carboxylic acid. We move to the next subtopic, which is the reaction of carboxylic acid. For your syllabus, I am going to focus 3 reactions only. First reaction of carboxylic acid is the reduction of carboxylic acid to primary alcohol. This is the vice versa reaction for oxidation of primary alcohol from the previous subtopic. In this reaction, carboxylic acid is reduced when treated with reducing agent such as lithium aluminum hydride in the presence of tetrahydrofuran in acidic medium, or by treating with boron in the presence of THF in acidic medium. The carboxylic acid will be reduced as it forms primary alcohol. Second reaction of carboxylic acid will be the deprotonation. In this reaction, carboxylic acids react with bases such as sodium hydroxide or sodium methoxide to form carboxylic salts in which the hydrogen of hydroxyl group is replaced with a metal cation. Further reaction of carboxylate salt with other reagent could form the carboxylic acid derivatives such as an ester and amide. The third reaction of carboxylic acid is the nucleophilic acyl substitution. This is the important reaction to form the derivatives of carboxylic acid. In the reaction of carboxylic acid with specific nucleophile, the hydroxyl group becomes as leaving group and being substituted with the nucleophile. Later, I will explain to you about this type of reaction as it forms the carboxylic acid derivatives include acyl chloride, ester, anhydride, and amide. Let's look some example in the reduction and deprotonation reaction of carboxylic acid. For the first compound, butanoic acid. In the reduction reaction, when butanoic acid treated with reducing agent, LIA, it will reduce first to butaldehyde. Then, it will further reduce to butanol. Next, when butanoic acid reacts with sodium hydroxide, it will be deprotonated and form carboxylate salts. Hydrogen is substituted with sodium metal. For the second compound, benzoic acid. Benzoic acid will be reduced into benzyl alcohol when it treated with reducing agent, while benzoic acid will go through deprotonation when it reacts with sodium methoxide to form salt. Similar with next compound, this carboxylic acid go through reduction to form primary alcohol. COOH will be changed into CH2OH. Then, when it reacts with sodium hydroxide, it will form carboxylate salt. Simply change hydrogen at hydroxyl group with sodium. Next, we move back to the third reaction of carboxylic acid. As I said before, the nucleophilic acyl substitution reaction is the reaction that produces the carboxylic acid derivatives. First reaction is the formation of acid chloride. In this reaction, acid chloride is formed when carboxylic acid is treated with thionyl chloride in the presence of heat. Hydroxyl group leave as leaving group and chloride ion will substitute hydroxyl group and attach with C double bond O. Next reaction is the formation of amide. An amide is formed when carboxylic acid reacts with ammonia in the presence of dicyclohexyl carbodiamide (DCC). Ammonia as nucleophile will attack C double bond O and hydroxyl group leave as leaving group. It will form primary amide. You can form secondary amide if you treat carboxylic acid with primary amine, while tertiary amide can be formed if carboxylic acid is treated with secondary amine. Next reaction is the formation of ester. An ester is formed if carboxylic acid reacts with any alcohol in acidic medium. Hydroxyl group leave as leaving group and take hydrogen from OH add alcohol to form water as this part will attack C double bond O. This reaction is called Fischer esterification reaction. Last reaction is the formation of anhydride. In this reaction, anhydride is formed when carboxylic acid reacts with acid chloride. Anhydride also can be formed when carboxylic acid is reacted with other carboxylic acid. I will show you the general mechanism in the nucleophilic acyl substitution. First step, nucleophile will attack electrophile carbonyl group. The pi bond is broken. One of bond moves to BS electron pair on oxygen. Next step is an electron pair on oxygen reforms pi bond and hydroxyl group comes off as leaving group. Then you will get the final product. Easy, right? Let's do some exercise in the nucleophilic acyl substitution. First, butanoic acid react with SOCl2 to form propanoyl chloride. Chloride ion will substitute OH group on COOH. At second reaction, carboxylic acid react with other alcohol to form anhydride compound. Simply drawing the product, redraw carboxylic acid until C double bond O part. Then, draw the alkyl group from alcohol and attach it with oxygen. Next reaction, carboxylic acid reacts with primary amine to form secondary amine. Simply substitute amine with hydroxyl group at C double bond O. Every time amine reacts with carboxylic acid, one hydrogen from amine will leave from group. In the last reaction, carboxylic acid reacts with acid chloride to form anhydride. Simply drawing the compound, redraw the carboxylic acid until C double bond O. Then, carbonyl group and alkyl group from the acid chloride. That's all. I want to show you guys the general mechanism of Fischer esterification reaction. First step, electron pair on oxygen at C double bond O take hydrogen ion. Oxygen become positive charge since it lose electron. Next, pi bond is broken. One of bond move to BS electron pair on oxygen as it neutralize oxygen. At the same time, electron pair on oxygen from alcohol attack C at C double bond O. Oxygen from alcohol become positive. Next, bond between oxygen and hydrogen is broken and move to oxygen as it will neutralize oxygen and remove one hydrogen ion H+. Then an electron pair on oxygen, which is in hydroxyl group, take hydrogen ion. Oxygen become positive. Last step, bond between carbon and oxygen is broken and move to the oxygen as water will move off from the compound. At the same time, bond between oxygen and hydrogen, which is from other hydroxyl group, is broken and reform pi bond between carbon and oxygen. it will form another hydrogen ion. That's all. This will be your exercise.